Number one on your lesson 13 practice was kind of tricky because they wanted you to find the weekly factor, but they didn't give you 2 weeks that are right next to each other. They gave you week 1 and week 3. So I still recommend organize it in a table. That usually helps me. And basically you need to find the pattern even though they're spread apart. So here's what I would suggest. They gave me week 1 to week 3. What's between 1 and 3? So I need to figure out what goes here, right? So I know that ordinarily I have to times by my factor of b to get to here, and then times it again by b to get there. So essentially you can set up an equation. 900 times b again gives me 8100. B being my factor that it's asking for. So another way to rewrite this, b times b is b squared. And we're solving for b, starting with what's farther from it. So what's the opposite of multiplying by 900? And whatever you do on one side of the equal sign. So that cancels the 900s on the left. I get b squared equals this, which I want to say is 9. Correct me if I'm wrong. Use a calculator. But I'm getting that it's 9. And b is not fully isolated. How can I cancel out squaring something? Opposite of squaring something would be to like, can you tell me what 10 squared is? Can you tell me what the square root of 100 is? No, not 100. Square root of 100? Okay. So square rooting something cancels out the square. And then whatever you do on one side, you do to the other side. That's what gets the b alone. And I know what the square root of 9 is, so just to show you. In your calculator, any calculator, it's a button that looks like this. People always call it like a division sign. It's not, it's a square root symbol. And if I'm trying to take the square root of 9, I just type it in like that. The square root of 9 is 3. So b equals 3. So 900 times 3 is what? 2700. 2700 times 3 is 8100. So that is my growth factor. I will say, like on your test, I don't recall having to do one where you have to do this. That's why I kind of came in for a loop yesterday. Normally, I just say find 2 coordinates that the x's are like right next to each other. And then do that thing I told you before, where you just like take the value, divide it by its previous value, and get the factor. But since it didn't give you any that are near each other, this is another way to still get it. Okay, and then from there it says what was the population when it was first measured. That's not easy to estimate because that graph is so tiny and it's definitely not at the 0. We know that when it's first measured is when x is 0. So I have what my factor is moving forward, 3 times by 3. When I have to work backwards, I have to do the opposite. So what's opposite of timesing 3? What's 900 divided by 3? So then this answer would be 300. That's what it was when it was first measured. We're continuing now the pattern backwards. It says write the equation now, because this is an exponential function. You need 2 things to make your equation for an exponential function. A, which stands for what? And what was my starting amount? So 300, they gave you some spaces, like, so that you put them in the right spot. The starting amount should never be attached to the exponent. Okay, so 300 is not attached to the exponent. B stands for what? That is what we had to multiply by each time. This is what? And that's what we go here. Don't put any extra spaces or things like that. But your B, your common factor, should always be attached to the exponent. So good, any questions? All right, so you can still continue working on this. I know like Mondays are the shortest amount of times to finish and ask questions, so later if you still have questions, feel free to ask. Today in algebra, we did lesson 14 though, which I think you guys being in this class are probably more better off than all my other students. Because we've already done changing a number by a percentage, right? I've told you before, this represents exponential functions, but so does this. Some are better to use in certain situations. Like the first one is better if it says that it's doubling, tripling, halving, timesing by a third, something to that effect. You use the first one. And then B is just 2 if it's doubling, 3 if it's tripling, whatever. This one is better if you have a percentage that is increasing by 25% each year, decreasing by 3% each year. The A still means the same thing, initial amount. What does the R stand for? Rate as a decimal. So if it gives you it as a percentage, you need to convert that to a decimal. Any percentage, say it's like 20% or something, you divide by 100%, that'll give you the correct decimal. But yeah, put it as a decimal, still to the x power, which is like time usually. And sometimes the time is just one. Sometimes you're applying the difference just one time. That's fine. And then the plus or minus just depends. Is it increasing or decreasing each time? And then we learned before, if it's greater than 1, it's growth. If it's less than 1, it's decay. So this might help you more with the 14 practice. But we've done it before. So I'm confident in you, even if you haven't had algebra yet today. That'll be the mastery rule today. It's going to be 80% or higher on lesson 14. And then go back and get 80% or higher on the other. So questions on that? So make sure that things are enabled like they should be, but if they're not, make sure you tell me. Yeah, let me know as you have questions, or I'll check in later no matter what.
And this one says the function f is defined by this equation. The function g is defined by the graph. So really great example of a test question, by the way, where they give it to you in 2 different forms and you have to compare. So in function g, which is supposed to be the graph, it's asking what the a is. So the a is greater than or less than 50. So in order to answer that, because this is not labeled, compare it to f of x. What's the initial amount of f of x? 50. And look at where the g of x equation compares to the f of x equation. Would that be higher or lower than 50? Higher, because as we go up on the y-axis, the numbers get bigger. So if it's sitting higher than the f of x there, then it must be greater than 50. The next part in function g, the b is either greater or less than 3. 3 is the common factor of f of x.
So when you compare them, stuff that is growing at a faster rate, because they're both growing, stuff that's growing at a faster rate is steeper. So which one do you think is growing at a faster rate, the G or the F? Which one looks steeper? I agree, the F. Like, even though G starts out higher than the F, at some point they intersect, and then the F continues to be greater. So that must mean that F is increasing by higher than what G is increasing by. Make sense? So for this one, I would say less than, and that is correct. That's how you can compare. Any other questions from any unit 5 stuff, Rita? 5 on lesson 13. The one about a ball was dropped? Okay. A ball was dropped from a height of 150 centimeters. The rebound factor of the ball is 0.8. About how high in centimeters did the ball go after the third bounce? So you can set up the equation. Although I do like the table for this one, since we're only doing, I guess, up to 3 of the pattern. So if I was making a table and we want to know after the third bounce, I would make these my X's, where X is, for like when X is 0, that's what we start at. So what was the height that it started at? 150. And it says the rebound factor, remember factors are things we multiply, so that's like my B value essentially, is 0.8. So to get to the next number, I have to times it by 0.8. So like 150 times 0.8 is 120. 120 times 0.8 is 96. 96 times 0.8 is 76.8. And it wanted to know after the third bounce, which answer is closest to this answer. But that's how I would do it, because it's not a lot that you have to keep the pattern going. You could also make the equation and then just use your calculator, where your initial amount is 150, your B is 0.8, and the X is however many times you keep the pattern going. But whatever gets you the right answer. Other question? Many unit 5 stuff. So number 2 on lesson 13. So here's a graph of the function f of x. It doesn't give you values for a and b, but the way it's set up is like our exponential function. So we know that b stands for what? Common factor. Now, in the first part of this lesson, so it has the same title for 12 and 13, it's just part 1 and part 2. We really focus on the B and like properties of it. So look at this graph. Would this be growth or decay? We learned that when it is decay, the B value is what? Less than 1. Okay, and then of course, I guess there's some exceptions, like there's numbers that are also less than 1, but that it can't be. So we're gonna go through each option and see, based on knowing that it's decay, we don't have any labels other than that, what it could be for the B. So can it be 0? 0 is less than 1, but that's kind of like, I guess, an exception to the rule. If I was timesing by 0 each time, what's going to be my answer no matter what? So really, I'd expect a straight line. for that. Does that make sense? Like if I have a bunch of values that I'm plugging in, if I times it by 0, I'm gonna get 0. It's gonna be a straight line, not a decay line. So don't pick 0. What about 1/10? Is that less than 1? Good, it's 0.1, so that's definitely decay. What about 1/2? Also less than 1. What about 9/10? What about when it's 1 exactly? And you could test it out. Whenever I time something by 1, does it change at all? So like if I were to have a table, and I don't know, the starting amount could be anything. But if I keep timing by 1 each time, it's not changing. So I wouldn't expect a curved line, I'd expect a straight line, so don't pick the 1. What about 1.3? Don't pick that one because that would be growth, not decay. And this graph is decreasing, so you gotta pick the ones that would also make the graph decrease. And then there's one more, 18/5. I'm out of room, so I'll add it up here. Is that less than 1? It's not. It's greater than 1. So just because it's a fraction doesn't mean it'll be decay. You have some fractions that when you divide them out, 18 divided by 5 is greater than 1. It's like 3 point something. So that's not less than 1. That would be growth. So really the only 3 you should pick would be these 3. And you might be shuffled on yours. But when in doubt, you could always graph it, like just play around with the numbers. Make a table like I did. And there's that. I have time for 1 or 2 more. Any other questions? 6 on lesson 14. Let's read over the lesson 14. So number 6 about military veterans. Okay. Military veterans receive a 25% discount on movie tickets that normally cost $16. You're gonna explain why 16 times 0.75 represents the cost of the ticket using the discount. So remember that for exponential functions, this is a good setup to use when it's a percent. All right, now the difference from what we've probably been doing in here is that we don't usually tend to like, I guess, simplify the inside. What's 25% as a decimal? So I think lately we just leave it like that because the calculator will read it the same anyway. 16 is the A, and we're only applying the discount once. So like my exponent would be 1, but you got to start getting used to also seeing that this, what's 1 minus 0.25? .75. Like we have to also start getting used to seeing it like this, where they already subtracted or they already added, like this is still the same. Okay, so when we're answering this, is it because each military ticket costs 75 cents? Does that make sense? So this is equivalent, but we need to pick why it's equivalent. So is it because all the military tickets are 75 cents? So remember, This is showing me the price of one ticket after the discount is applied. So it's 16, which is the normal cost, times what it's keeping of its price, not what the discount is, what it's keeping after the discount. So it's not gonna be this one because that doesn't make sense. 25% off doesn't make the $16.75. 25% should be triples, no. 25% can be subtracted from the whole cost, 100% we do the 75% or 0.75. And then saying that this is incorrect, we already said it is correct. So it would have to be this one. So if you guys continue to have questions, you know, don't be shy, email me, talk to me tomorrow. But